Hello students, let's learn today factorization. This word factorization is not new for you. Already we have learned in previous classes, but in this class we have to learn how to factorize algebraic expressions. In previous classes we have learned how to factorize natural numbers. And when we are factorizing natural numbers, we are splitting the number as the product of prime factors. And we know that factorization means splitting of a number as the product of prime numbers or prime factors. Now, let us learn how we are factorizing algebraic expressions. Let us take one example 9a square b square. How we are factorizing? The numerical part 3 is multiplied 2 times, that is 9. A square is a is multiplied 2 times and b square means b is multiplied 2 times. In this way we have to factorize the algebraic expression when it is single term. When we factorizing an algebraic expression, that means we have to split the total expression as product of its factors. The factors may be number, may be variable, or sometimes it is algebraic expressions. Now we have to learn some methods how to factorize algebraic expressions. Method of common factors. In this method, we have to take as common, we have to find the HCF of the terms and we have to take that HCF as common. Here 2a plus 2, 2a plus 4 is two terms expression. We can split each term as the prime factors. 2 into a, 2a and 4 is 2 times 2. Now, what is common factor here? In the first term and the second term, 2 is the common factor. So, we have to take 2 as common and from the first we are getting a left and from the second we are getting 2. Now, 2 is multiplied by a plus 2 and we are getting the total expression as product of its factors. Now, this is the method of common factors. Now, let us learn when the total expression is not having any common factor. We can make it into groups. Let us take one example. Suppose ax minus ay plus bx minus by. Here there is no any common factors which is common for all the four terms. But in the first term we are having common a and the second two terms we are getting common as b. So we can make it groups. Here in the first group a is the common and the second group b is the common, and after taking out those common factors we are getting two terms as total. Now in these two terms x minus y is common and after taking x y as common we are getting a plus b. Now this total expression is in product form of factors. This is the method of grouping method. Let us discuss now how to use algebraic identities. Already we have learned the algebraic identities. These are the algebraic identities. Now how we are using these algebraic identities in factorization. Let us take the example a square plus b square that is equal to a square plus 2ab plus b square. Here a plus b whole square is the factorized form. So any expression which is in this form a square plus 2ab plus b square, we can easily convert it into a plus b whole square. When p square plus 10p plus 25, we are getting p square as square of p and 25 as square of 5, and 10p we are getting 2 into p into 5. Here a we are getting p and b we are getting 5. So we can express this expression, total expression, as p plus 5 whole square. Identity a minus b whole square. Here a minus b whole square is in factorized form. Now let us take one example. 4a square minus 12ab plus 9b square. Here 4a square means 2a whole square and 9b square equal to square of 3b. And minus 12ab is 2 into 2a into 3b. Here we are getting a as 2a and 3b as b. Now we can express this expression as a minus b whole square, that is equal to 2a minus 3b whole square. Let us take another identity, that is a minus b into a plus b, that is equal to a square minus b square. Here a square minus b square is not factorized. When we are getting any expression in this form a square minus b square, here 25a square minus 36b square, here 25a square is 5a whole square and 6b whole square is 36b square. So we are getting a square minus b square form, and here we are getting a 5a as a and 6b as b. So we can factorize this total expression as 5a plus 6b into 5a minus 6b, that is identity a square minus b square. So these are the identities. Now let us take another method, which is factorizing trinomials. This is also called splitting up middle term. When a trinomial is in this form ax square plus bx plus c, where a, b and c are integers, and we have to split, in this method we have to split the coefficient of x, that is b, in such a way that a plus b, when we are finding the sum it should be b, and when we are getting the product it should be this ac, ax square plus bx plus c. Now we have to split b in such a way that both terms, when we are adding we are getting b, and when we are finding their product it should be the product of first and last term. This is splitting of middle term. Let us take one example. X square plus 5x plus 6. Here 5x we have to split in such a way that those two terms, when we are adding we are getting 5x, and when we are multiplying we should get the product of first term, coefficient of first term and the last term, that is equal to 1 into 6. So we have to factorize 6. 6 we can get 1 into 6 or 2 into 5. So when we are adding 2 and 3 we are getting 5. So 2x plus 3x we can split. Now the total expression is x square plus 2x plus 3x plus 6. Here we are getting the total expression as 4 terms. Here we are not getting any common factor, so we can use the grouping method. Here x square plus 2x having common factor as x, and after that x plus 2 left, and the second group we are taking common as 3, which is x plus 2. Now after that we are getting x plus 2 as common in both terms. After taking out common x plus 2 we are getting x plus 3 as common. Now the total expression is in factorized form. It is the product of factors. So this is the factorization of algebraic expression in splitting up middle term. Hope you enjoyed learning. Hope you understood. Thank you.